Pretty good handle on this? No, you don't? All right, Christiana, you think you have a good handle on how to do these?
Absolutely not.
All right, so then Grant says he has no clue. Sam, how about you? And Christian?
For what?
Do you know how to do these?
Kind of.
Kind of? All right, so let's just pay attention here. All right, on the first one, it's going to walk you through the steps. And this is how it's going to appear, Thursday. And you know how to do all of this. We just need to put it all together. Axis of symmetry cuts that in half. So you need to do negative b over 2a, and you should get x equals negative 1. Okay, when you're done. So b is 2, okay, right here. A is 1. And then so you get negative 2 over 2 times 1, which simplifies to negative 1. All right, how do I then get the vertex? Okay, from that point. Jaylee, do you know how to get the vertex from that point?
Use the formula?
Which formula?
The negative.
We already used it. So someone say no. We'll say no. So Allie's going to tell us how. You take whatever that number is and you plug it into y. Whoops. You plug it into the equation, and so it's going to be y equals negative 1 squared plus 2 times negative 1 minus 6. And you're going to get negative 7. So that's where we get that negative 1, negative 7. So we draw in the vertex, or the axis of symmetry, we put the vertex in. Y-intercept is the c value, which is always whatever the constant is. So it's 0, negative c. So now I got 2 points. The other 2 points have to be on the same side as the what? As the y-intercept. So it tells you which y values or x values to pick. The y-intercept is to the right. I already used 0, so I pick 1 and I pick 2 and I plug those into the equation. All right, it's not going to do me any good to explain the others if you haven't done them. If you have, you should be pretty good. Flip it over to the other side. Let's take a look, and we're going to do number 1 together. There, number 4 actually. Got it there? Okay, so let's take a look at the next one. What is the equation it gives us? Jordan, what's the equation it gives us?
Number 1.
For the first one on the back.
On the back. Y is equal to x squared minus 6x plus 2.
All right, everybody agree with that? Which way does it open? Which way is it going to open? Before I know anything, before I do anything, which way is it going to open? Austin, which way is it going to open? Up or down? Why did you say down? Why did you say down? Okay, it only opens down if the negative is on the x squared, in front of the x squared. If the x squared is positive, it's going to open up. Right, Rachel?
Yep.
How do I find the axis of symmetry, Tommy? Yeah, it even has it right in front of you. Oh, no, this one doesn't, so you have to turn on the other side. Now, my A is 1, my B is negative 6. What's my C? It's 2. So the axis of symmetry is x equals negative b over 2a. So I'm going to plug that in and see what I get. Do that now and see what you get, but then don't do anything else because you got that wrong. The rest of it's going to be wrong. We're on the back. Oh, there it did. Okay. All right, well, that's fine. All right, what'd you get? What's that? All right, well, put those numbers in. Actually go through the steps. Don't. This is not a spectator sport. This is a participation sport. Which means you don't want to do the work, see what you get. Plug those in. You guys have to check this. Did you put that down?
Parabola. You want to know the x, figure out the y. You have to turn backwards. What? Find out. So I said, wait. All right. What do you got?
Me?
Well, you gotta figure out what X is. You gotta plug in.
And then,
You gotta plug in A. You gotta do that. So, Connor, what'd you get? You got 3.
Yeah.
All right, I agree with that. Okay. So it's minus, B is -6, A is a 1, so it becomes 6/2, which is 3. On your line, it should say, where it says axis symmetry, you should write x equals 3. You should write x equals 3. Now I'm gonna go old school here, and I'm just drawing this out. Bless you. All right, so Grant, at this point here, you draw a dotted line, a vertical dotted line at x equals 3. So it basically cuts everything into 2 things. You got something to the right, something to the left. So draw that dotted line. You got it?
Yeah.
How do we find the vertex then? How do we find the vertex? Okay. Well, if you need to flip it over on the other side, it basically tells you how to do it. But let's just see if we remember. Same.
Plug x into the original equation.
Plug whatever you got in for the axis of symmetry, that x value, into the equation. So it becomes y equals 3 squared minus 6 times 3 plus 2. And then go through the math. London, what'd you get?
I got -7.
-7. Can anybody agree with that? All right, so we got agreement. So she got -7. Now, when you write it on that line, you have to write negative. Hold on here. It is the point or +3. -7. And then that is what should be on that line. You got to write it as a ordered pair. You got to write it as an ordered pair. Okay. So 3 -7 is going to be on that dotted line. It should be. Okay. So you got that point. And we said it's going to open up because it's a positive x squared. Now, what's the next piece of information on there, Colin? What does it ask us for next?
Y-intercept.
All right, y-intercept. Christian, do you know how to find the y-intercept?
It's the number without a variable,
And what would it be in this case?
+2.
+2. It is the c value. It is the number without any variable. It is the 2. And you need to write it as 0, 2, because the x value is always 0. Don't just say 2. Okay, now this is where everybody's having issues, and I understand it's a little complicated the first couple of times. We got to come up with 2 other points, because that doesn't give me enough information to graph this thing exactly like I did. I got to come up with 2 other points. Question is, you always start with the x values. What 2 points would I use here? Okay. Do you have any ideas? She says 1 and 2. Now, I would agree with her. We say you want to take a look. The y-intercept is on the left side of the axis of symmetry. I want to pick points close to the axis of symmetry. When I say points, I'm talking about x values. Okay, well, the two closest would be 1, 2, and then 1. So I'm gonna plug those in and figure out what I get. What do I do with these x values? You plug them into the equation, y equals, what is it, x squared minus 6x plus 2. And then you see what you get for the y value. So plug in a 1, see what you get. Plug in a 2, see what you get, and then you'll put those two down. Okay, then you'll put those two down. And 1, if I plug in 1 squared minus 6 times 1 plus 2, negative 5 plus 2. What do we get?
Negative 3.
So you got negative 3. We agree? So y equals negative 3. Okay, that's when I plug in 1. So 1, negative 3, I put a dot there. And now what do you get? Anybody have what we get when we plug in 2?
-6.
It says negative 6. Let's go with that. That's correct. 2 is negative 6. Now you should have about 3 points on one side of the graph, which means there's going to be how many points on the other side? 3. We talk about the mirror effect. You got to figure out how far away from the axis of symmetry is to figure out your other points. Yeah, I'm going to start with the first one closest. It's 1 unit away. This one's 2 units away. And the y-intercept is 3 units away. And so draw in your graph. Should look like that. And yeah, those 2 points can be difficult, but you got enough information, hopefully, to be able to find that axis of symmetry, find the vertex, and kind of go from there. Now, for that last part, let's take a look at the last one. Here's what I would tell you to do. Take your equation, find the axis of symmetry, and then find the vertex. You should always do that. That'll tell you the highest point. So use x equals negative b over 2a, and then find the point where that hits. Now, for this one here, opposite of b would be negative 72 over 2 times negative 8. I get 4.5. Plug in 4.5 into that equation. Okay, just go ahead and do that. Make sure we get the same thing. Plug in 4.5 into the equation. Grant, let me know what you get then.
How did we get 160 feet?
Well, Grant, you got what we get when we plug in 4.5? Did you get it yet? What are you typing in there?
Oh no!
What are you doing wrong?
I just cleared it off.
Alright, hold on.
You know how to use the calculator?
Using the calculator, pushing buttons? Yes.
162. When you plug in 4.5, Preston, you get 162, which means that is the vertex. Okay? Now here's what's always going to happen. That's going to be the maximum height for all of these problems. Like this, they're going to start at 0. Okay? And it's going to take 4.5 seconds to get to that maximum height. Well, how long is it going to take to come back down to the ground? It's going to take the exact same amount of time it took to get up to the height. So if it took 4.5 to get up to the maximum height, it's gonna take another 4.5 seconds to drop to the ground, which means the total time in the air is always gonna be double the time it takes to reach the maximum height. That's always gonna be the case. So for all of these, what I would tell you to do is find the vertex, and you can figure out all your answers from there. Okay, because it'll tell you how long it takes to get to that height, what the height is, and then you just double the amount of time to get all the way back down for that. Now, I used a scale of 10. You could have used a scale of 20 and it looks a little bit different. I know you didn't have to do that one. Okay, but that would be the case. All right. All right, hopefully that helped a little bit. All right. We're going to keep going over that. We do have, we're going over section 9.4 today, and we do have 2 days of review. Section 9.4 is we're going to figure out what makes these graphs move is by looking at their equations. And I do have some guided notes for you. Man, we got to work on how you on the end of the
No, I had it right there, and I actually had it clear, so.
3 times.
No, I don't know. Just finishing the problem. What is this?
Oh, Chris, you got one? Nope. You got one?
Yeah.
I dropped it.
Now, I know this is not maybe as big as I'd like it to be, but y equals x squared is the base function. And when you graph that, okay, that's a parabola that opens up, hits at 0, 0. We want to take a look at what makes something wider, what makes it narrower, what moves it left and right, what moves it up and down. Okay, because if I graph another function, say x squared minus 6x plus 2. I want that to be an x. Okay. It's not in the same place. It's not in the same place. It's not the exact same graph. So we want to figure out what makes it move. Okay, what makes it move? And the main thing is where that vertex goes, how to figure out where that vertex is. And so we're going to take a look at a couple key things here. All right, so if you look at this, and these are what we call transformations. Transformations is things that change, like the original graph. The original graph is just x squared. What makes it wider, what makes it narrower? Okay, we said the value of A determines the direction it opens, but it also tells us the width of the parabola. So if you look at that first little graphic there, okay, if you look at the number in front of x squared, it's either going to make it wider or it's going to make it narrower than the original. What makes it wider or narrow is that number. If it's bigger than 1, okay, then it's going to be narrower. And what do those little bars mean? Remember? Absolute value. So it doesn't matter whether it's positive or negative, just treat it as a positive. Then it's going to make it wider if it's smaller than 1, like if it's a fraction. So just take a look here. That's x squared. If I make it 0.2 x squared, should that be wider or narrower? Let's just see what your gut says. Zach? Think of it the opposite way. If it's less than 1, there's x squared. Is that wider or narrower? It's wider. Okay. If it's bigger than 1, say it's a 3x squared. There's x squared. 3 is going to make it narrower. Now, the only thing that negative is going to do is flip it upside down, but you'll still have wider or narrower. So if I make it negative 0.2 x squared, it's going to flip upside down, but it's still going to be wider. Just take away the negative. Think about that. So as we take a look, hold on. So as you take a look at those two on your graph, which one would be narrower between f of x equals 3x squared and 0.5x squared. So all you got to do is look at the number in front of the x squared. It doesn't matter about anything else. Okay? Why call it?
3x.
That would be narrow. So yes, so f of x is narrower. F of x is narrower. So if I would graph those, let me go to clear the others out. Can they see these at all, Mr. Schler back there?
Yeah.
Okay, good enough to do it?
Yeah.
So there's 3x squared. Here's 0.5x squared. Okay, there's the first one. Clearly that is narrower than the second one. So the bigger this number is, the narrower it is. All right, for that second set, negative 2x squared and negative 0.25x squared. Okay, they got the negatives in here. Let's see if we can understand this. Preston, what do you think? What's your gut tell you? Which one's narrower? It is negative 2x squared. Okay, it is. So for here, if I plug in negative 2x squared and I plug in negative 0.25x squared, they're both going to open down. There's the first one. Second one's a lot wider. Okay, really, you don't even need to worry about the sign. You think about the absolute value, that is 2. The absolute value of this one is 0.25. The bigger the number makes it wider. So, or excuse me, the bigger the number makes it narrower. So f of x is narrower. So f of x is narrower. Okay, now what's that next piece? To move things up and down. To move things up and down, the easiest way to do this is you add something after the x squared. So just to make sure that this makes sense, I'm going to make this x squared. And then if I make this second one x squared plus 5, take a look at the comparison. There's x squared, and it just shifts it up. Doesn't change anything else. What do you think you need to do to make it go down? Minus it. So if I do x squared minus 6, it's going to go down 6 units. So that's going to move it up or down. Okay. If it's a negative, okay, it's going to move it down. Now, what that does is it changes the vertex. What is the vertex right here? And this is going to be a key thing. The vertex is 0, 0. What's our new vertex for this first one? Make sure this makes sense. It's going to be 0, 5, because I moved it up 5. And the second vertex here is going to be 0, negative 3. All right, flip it over. Left and right, though, it's a little bit more complicated. If you want to move it left and right, you got to put parentheses and put the squared on the outside. And it's kind of backwards. So y equals, I'm going to clear that out. If I put in x minus 3 squared, there we go. You see the minus, your first instinct is a negative number. Actually, it's going to move in the opposite direction. Okay, so this moves it to the right 3. So this point right here would be 3, 0. That would be the vertex. If you have a plus 5, it's going to move it to the left. Okay, so this is kind of opposite. So that would be at negative 5, 0. Okay. All right, where are we at? Okay. It says identify the coordinates of the vertex. Make a table of values using the vertex and 2 points to the left and 2 points to the right. Graph the function. So we're going to have to plug some values in. All right, looking at that, where's the vertex going to move to? The minus 1 moves it which direction? Okay, Jordan?
In the positive,
Moves it, yep, and then how far?
just one.
It's going to move it right 1. And then what does the plus 2 do? Jordan?
Doesn't it help, like, move it up to?
Moves it up 2. So where's my vertex now? Now you gotta think, where does it usually start at? Make sure we understand that. You gotta make sure. Connor, where does it usually start at? All right, and it is a good question. That's why I asked it. We are always comparing it to x squared. And the x squared always starts where? 0, 0. So you got to understand, where is it moving from? So it's moving from 0, 0. What is the coordinate of my new vertex at this point? Okay, see we're making sense. Grant, am I making any sense? What would be the coordinate of the new vertex? Grant.
I don't know.
All right. Here's that's important. It normally starts at 0, 0. This tells us it moved right 1 and up 2. So where is it going to be after it goes right 1 up 2? What will be its coordinates?
1, 2.
That's how we get the vertex's coordinates right there. Okay, so for the put somewhere on there, the vertex is 1, 2. Now, here's a little bit of the hard part. We're going to do a chart. What is it? You just cannot do -2, -1, 0, 1, and 2. That's not going to help us. What does it tell you to do? There's 2 points to the what? Left of the vertex, and what else? 2 points to the right of the vertex. So before I do this, I'm going to kind of just do this. My vertex has an x coordinate of 1. 2 points to the right would be 2 and 3. What would be 2 points to the left? Okay, if I'm starting at 1, the next point would be 0. Those are the 5 points I want to use. I want to use -1, 0, 1, 2, and 3. 1, we already know, should be a 2. This is your equation. All right. Why don't one of you got 2 people at your table, split up the work. One of you plug in -1 and 0, the other one plug in 2 and 3. See what you get. Plug them into that, and then compare.
What's the last X bar? What's the last X number? What's -1, 0, 1, 3?
All right. So plugged in
Which number?
2.
The -1.
Okay, so you got 3. Put that in your chart, and then plug in 3. What's that? Do the same thing. So you plug in 2 to the x side, which was plugged in 2 there. Okay, now plug in 3 there.
This homework.
We're gonna do something together.
Yeah.
All right, -1. Zane, what did you get
I got 6.
when you plugged in -1?
Yeah.
Okay, he says 6. -1 minus 1 is -2. When you square that, you should get 4. 4 plus 2 is 6. I agree. All right, how about 0?
3.
0 is 3. I agree. Now I'm going to plug in 1 just to show you that it works. What is 1 minus 1? 1 minus 1 is 0. 0 squared is 0, and then 0 plus 2 should give me 2. All right, Rachel or Morgan, who plugged in 2 and 3? What'd you get?
3 and 6.
You should get 3, and then you should get 6. So now go over to your graph, and I get -1, 6. Oops. you get negative 1, 6, you get 0, 3, I get 1, 2, I get 2, 3, and then I get 3, 6. And it looks like that. Okay, so you gotta plug in those numbers. We're gonna do one more there together. We're gonna do one more. And then I wanna do some of the problems from that sheet, Mr. Schler, just so we're on the same page. And actually, let's jump to that, the sheet he just gave you. Okay, I don't have it up here, but let's just do that and make sure we're on the same page. We're gonna start there on the left-hand side. You got an extra copy? There we go. Okay. All right, as you look at those. We'll just start with number 1. Which of the following graph is narrower? So you got f of x or g of x. Take a look at that. All right, Connor, you see where we're at?
Yeah.
All right, do you know which one would be narrower? That was a very confident answer there. You are correct. You only have to look at the x squared. Everything after that for wide or narrow, don't even consider. So really, I just look at 2x squared versus x squared. Okay, if that's bigger than 1, it's going to make it narrower. So f of x is narrower. Okay, for number 3, we're just going down that left-hand column. For number 3, now you don't have anything other than x squared. Which one would be narrower? Which one would be narrower? Okay, same. F of x is 4x squared. That would definitely be narrower. Good. So f of x is narrower. All right, now for 5, read the directions. Using the graph of f of x equals x squared as a guide, describe the transformation, identify the vertex. Well, for f of x equals x squared, this is the function. It always hits at 0, 0, opens up. Basically, describe the transformation. Does it move left, right, up, or down? That's what you have to write, and then you have to tell me the vertex. All right, so as you look at number 5, do you know which way it's moving? Okay, based upon that column.
Down.
How far? 2. So since you only have f of x equals x squared minus 2, you don't have anything in parentheses. Here's what you need to put. You need to put down 2, and then the vertex. What would be the coordinates of the vertex? The original vertex for all of these is 0, 0. That's the original. So Tommy, what do you think the new vertex would be?
0.
Which way did it move? So down. So what are the coordinates of that point? Flip it around. 0, negative 2. Your vertex is going to be 0, negative 2. Because if you flip that around, you're going to get everything mixed up. All right, take a look at 7. Take a look at 7. All right, Jay Lee, you getting any, feeling confident on this one? No, not really. Does it move left? Does it move up or down? Yes or no? To move up or down, it has to have a plus or minus outside the parentheses. Does it have anything outside the parentheses? So it does not move up or down. Inside the parentheses, it moves it left or right, but it's always the opposite. So it doesn't. So normally you think where -1 is going to move the other way. So it's not going to go left. It's actually going to go which way? Right. So this one's going to go right 1. Vertex. So what's its Hanan? What's its vertex going to be? What do you think? Okay, where does it start at? Where's the vertex start at?
Is it Or 1, 0.
We always go back to the original vertex, which is at 0, 0. So yes, when it moves right 1, it's going to end up at 1, 0. Okay, so for each one, you restart it at 0, 0. Now, as you take a look at 9, g of x equals x minus 4 squared minus 3. So this one will move both left and or right, and it will also move up or down. Zach, what do you think?
First, since the negative on the inside, you move right 4.
Okay, good. The x minus 4 makes it move right 4. And what does the minus 3 on the outside do?
To go down 3.
Down 3.
So vertex would be 4, negative 3.
So the vertex would be 4, negative 3. Agreed. Agreed. All right, look at 11. Look at 11. Don't make 11 harder than it is. Yeah, but there's a tendency to make that. This one does not move left or right because there's no parentheses around with it, like an x minus or an x plus. It doesn't move. But which way does it move? Which way does it move, Jordan?
7 to the left.
Not to the left. Not to the right.
Up.
Up. There we go. H of x equals 3x squared plus 7. That's going to move up 7. So it means its vertex is going to be 0, 7. Okay. All right, what I need you to do is finish this sheet. If you get 13 and 14, we didn't get quite to those. They're a little bit more difficult. If you're not sure, just hold off on 13 and 14. I want you to try them. But make sure you go ahead and do the right-hand side, 2 through 12, and then 13 and 14, if you think you can get those. But you really got to read directions there. We're going to hit this again tomorrow, for sure.